So that's all about factorization using middle term split. When we have a trinomial, which is a quadratic equation or a quadratic polynomial, when it converts to quadratic equation, putting the quadratic equation equal to 0, whatever factors we have found out, that will give us the roots of the equation, that we'll study in the next class. Now moving to factorization further. How to factorize by grouping and by taking out the common factor. This is applied in the case of a binomial and in the case of a quadrinomial mostly. Example 1, if I have a polynomial which is a binomial x square minus x, then we can see that in both the terms we have x as a common factor. So taking that x as a common factor, the other factor would be x minus 1. How? If I take x as a common factor, then from the first term x square only x will remain, and the second term we have already taken common. So x into minus 1 would have given you minus x. That is why within the bracket I write minus 1. So when I open the bracket, I get back the same expression. Example 2, if we have a quadrinomial AB plus BC plus AX plus CX, there are 4 terms. So what we will do, we'll first group them in group of 2. Grouping AB plus BC. Grouping AB plus BC, I can see B is the common factor. If B is the common factor, then inside I'll have A plus C. If I take A as common factor, B as common factor, then out of the first term only A remains, and from the second term only C remains. Similarly, from AX and CX, if I take X common, I'll be left with the factor A plus C. This is very important step. Here these two factors must be same. If these two factors are not same, then my factorization is not correct. So if these two factors are same, then they can be taken as common from the binomial. Taking A plus C as common, the other factor will be B plus X. So given any polynomial, you must always try to factorize it first by taking common, and then we should move to the middle term split. So far we have learned how to factorize a quadratic polynomial. Today we will learn how to factorize a cubic polynomial. To factorize a cubic polynomial, we have to break the cubic polynomial into 2 parts. First, I have to break it, or we have to split it into 2 factors, one factor being a linear polynomial and the other being a quadratic polynomial. Let us see how we do it. Since the splitting of middle term method cannot be done in a cubic polynomial, by visual inspection, we'll find out one of the zeros of the polynomial, which will give me a linear polynomial as one of its factors. Let us understand this with the help of an example. Suppose I have to factorize x cube minus 23x square plus 142x minus 120, which is a cubic polynomial, the highest power of the variable being x cube. Now by inspection, we have to look for all the factors of minus 120. Some of these factors are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6, plus minus 8, plus minus 10 and plus minus 12. Now what to do next, and so on. By trial, let us start with plus minus 1. Starting with plus 1, we can see if I substitute the value of x as 1, I'll get p1 equal to 0, which makes x minus 1 the 0 of the polynomial px. So if x minus 1 is a factor of px, then x minus 1 is one linear polynomial which is a factor of this. So, but x minus 1 is only one of the factors. To find the other factor, what do we need to do? we have to first divide. X minus 1 is one of the factors. So, dividing the given polynomial by x minus 1 will definitely give me the other factor. So, if I divide this by x minus 1, or simply in place of x, if I split up in place of x cube, if I write x square into x minus 1, and if I split up, what do I get? X square into x minus 1 minus 22 into x minus 1 plus 120 into x minus 1. See, what have I done here? I have grouped and taken common. Grouping and taking common, what do we see? That x cube, I have split up 23x square as minus x square as minus 20 and minus 22x square. Then 142x have split up as 22 plus 120. We have split each term into two parts so that I can take common. Carefully see, x cube is a single term which has not been split up because it's a single term. The first term is not split up. Then 23x square has been split up as minus x square as and minus 22x square. 142x have been split up as 22 plus 120. It has been done so that I can take x minus 1 as common. Taking x minus 1 as common, I am left with x square minus 22x plus 120, which is a quadratic polynomial. One of the factors is x minus 1, the other factor is x square minus 22x plus 120, which is a quadratic polynomial. Now, this quadratic polynomial can be further middle term splitted, it can be middle term splitted, and we can find out two more factors. Since it's a cubic polynomial, it will have 3 zeros or 3 factors because the degree of the polynomial, let us recall, the number of zeros is always equal to the degree, of the polynomial. The maximum number of zeros will not exceed 3. There will be 3 zeros, the first being x minus 1, the remaining 2 we can find it from here. There is yet another method of finding out the quadratic polynomial, which is a factor of this cubic polynomial, that is just by dividing the cubic polynomial by the long division method by this linear polynomial. Let us see how. So, Px was my x cube minus 23x square plus 142x minus 120, and we just have seen that x minus 1 is a factor of Px. Now, dividing this by x minus 1, let us see what is the result. So, if I divide the cubic polynomial by the linear polynomial which we have calculated, how do you go? To divide x cube minus this 23x square plus 142x minus 120 by x minus 1, I first look at x minus 1 and think that with which number will I multiply x minus 1 so that I get x cube as the first term. Obviously, I have to multiply with x square. Multiplying x square with x minus 1, I will get x cube minus x square, x cube minus x square. On subtraction, I will get minus 22x square, this will cancel, and I will bring down plus 142x. Next, with which number shall I multiply x minus 1 to get minus 22x square as the first term, that is minus 22x. Now, multiplying minus 22x with x minus 1, I will get minus 22x square minus 22 plus 22x, because minus 22x and minus 1 will give you plus 22x. On subtraction, 142 minus 22 will give you 120x, and then I will bring down the last term minus 120. The number which multiplied with x minus 1 will give me 120x is simply plus 120. So, finally, I will see that I am getting the remainder 0. If I am getting a remainder 0, then obviously this is my quadratic polynomial, which is a factor of the cubic polynomial. So, this is my first factor, which is a linear polynomial, and this is my quadratic polynomial, and both of them when multiplied will give me, so x minus 1 into x square minus 22x plus 120 will give me this cubic polynomial Px. So, this we have done, and we have already seen that how to do it by factorization also and by long division also. Now, these are split, the cubic polynomial is split into two factors, one is a linear factor and the other is a quadratic factor. Next, I will factorize the quadratic polynomial to get further factors by middle term split. Let us recall how we did middle term split. Here my A is 1, B is minus 22 and C is 120. That means the product AC is positive and the sum B is negative, which means both my factors will have to be negative. So, by using the middle term split, we have x square minus 22x plus 120 equal to x square minus 12x minus 10, because minus 10 and minus 12 will give you minus 22 and minus 12 and minus 10 will give you a product of plus 120. So, since we have already done it earlier, we are not going into detail of it. So, we can see these two are other two factors and x minus 1 was another factor. So, we have three different linear factors, x minus 1, x minus 12 and x minus 10. So, the zeros of the polynomial are 1, 12 and 10, which means putting any one of these values will give the 0 of the polynomial or will make the polynomial equal to 0. So, that is all about factorizing a cubic polynomial.